You are tuned to Iri-e-learning, and I am your host, Teacher. In this structure and bonding lesson, we will examine why atoms bond. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to explain why atoms bond, identify the electron structure of metals and nonmetals. We begin with formation of bonds. The first thing we need to know is, why do atoms bond? The reason is very simple. Atoms bond to obtain a stable electron configuration. Now, we have highlighted stable electron configuration because there are two things in it that we need to know. We need to know what is electron configuration and what does it mean to be stable. So what is electron configuration? Note that electron configuration is abbreviated EC. Now, the electron configuration of any atom is the arrangement of the electrons on the shells of that atom. There are particular rules that guide the arrangement of the electrons, and we are dealing with the first 20 elements using the following rules. Now, the first shell, which is a shell directly around the nucleus of the atom, can only hold up to a maximum 2 electrons. The second shell holds a maximum of 8 electrons, and so does the third shell for the first 20 elements. However, if you're looking at atoms beyond the first 20 elements, the third shell can hold up to a maximum of 18. But for this course, we will say that the second and third shells hold a maximum of 8 electrons each because we are only dealing with the first 20 elements. Now, the fourth shell can hold a maximum of 32 electrons. When the electron shells of an atom are being filled, note that the lower energy levels must be filled first before filling the next energy level. In other words, the first shell must have its maximum of 2 electrons before you can start putting electrons on the second shell. And the second shell must have its maximum of 8 electrons before electrons start entering on the third shell, and so on. Now that we know how electrons are arranged on an atom, it's important to find out what does a stable arrangement or a stable electron configuration means. A stable electron configuration occurs when all the shells of an atom contain the maximum number of electrons, including the last shell. And so overall, the atom now acquires an electron configuration or an electron arrangement that is similar to an inert gas. So how do atoms go about obtaining a stable electron configuration? They will do one of three things. The atoms will either lose, gain, or share valence electrons to acquire a stable electron configuration. This will become clearer when we explore the different types of bonds in the upcoming lesson. Electron structure of metals and nonmetals. In other words, how do we use the electron structure of an atom to determine whether the atom is a metal or a nonmetal? So how do we identify metal atoms? The metal atoms have 1, 2, or 3 electrons on their valence or last shell. There are 2 exceptions to this rule, hydrogen and helium. Now, hydrogen has 1 electron on the last shell, which happens to be its first shell, as well as helium has 2 electrons on its last shell, which is also its first shell. Now, these atoms are nonmetals. So we have to keep in mind that atoms that have only 1 shell, they are always nonmetals. So if the atom has only 1 electron shell with electrons on it, that atom is a nonmetal, even though there may be 1 or 2 electrons on that single shell. So how do we identify nonmetal atoms? Well, nonmetal atoms have greater than 3 electrons on their last shell or their valence shell. Keep in mind that hydrogen and helium are exceptions to this rule because they have 1 and 2 electrons respectively on their last shell. And we identify these nonmetals because they have only 1 electron shell. If you have not yet done so, you may want to review the Unit 2 lesson on diagrammatic representation of atoms. We have provided the link right here. This will be important so that you can understand the scientific drawings or illustrations used to represent atoms. So let's see. Can you identify whether these atoms that are drawn are metals or nonmetals? The first atom has 3 shells: the first shell, the second shell, and the third shell, where the third shell is the last shell. Note that once there is a third shell, the first and the second shell contain their maximum number of electrons. The first shell has a maximum of 2, and the second shell has a maximum of 8 electrons. Therefore, our interest is only in the number of electrons on the last shell. This atom has 1, 2, 3, 4, 5 electrons. Recall from the lesson that if an atom has 4 or more electrons on the last shell, it is a nonmetal. Also, if the atom has only 1 shell, even though there are less than 4 electrons on that single shell, it is likewise classified as a nonmetal. Since this atom has 5 electrons on the last shell, it is nonmetal. The second atom has 2 shells. The second shell, which is the last shell, has 1 electron. Recall from the lesson that if an atom has less than 4 electrons on the last shell, it is metal. This atom, therefore, is metal. The third atom is large with 4 electron shells. The last shell contains 2 electrons. Since this atom has less than 4 electrons on the last shell, it is metal. The final atom has only 1 electron shell. So then, without investigating the number of electrons on the shell, we know it is nonmetal. Recall that atoms that have only 1 shell are always classified as nonmetal, as is the case with hydrogen and helium. And this is an atomic diagram for hydrogen. The lesson summary points include: atoms bond to achieve a stable electron configuration like that of an inert gas. Electrons are arranged in a fixed quantity on the shells or energy levels. An atom with a stable electron configuration has the maximum number of electrons on all the shells. Atoms lose, gain, or share electrons to obtain a stable electron configuration. The number of electrons on the last shell of an atom generally indicates if the atom is a metal or nonmetal. Metal atoms typically have 1, 2, or 3 electrons on their last shell. Atoms with only 1 shell are always nonmetals, namely hydrogen and helium. Nonmetals have greater than 3 electrons on their last shell. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Identify the statement that accurately explains why atoms bond. Atoms bond to A. Look like helium. B. Obtain an electron configuration similar to inert gases. C. Increase the atomic size. D. Gain more electrons on their last shell. The answer is B. Atoms bond to obtain an electron configuration similar to inert gases. Question 2. Which statement best explains the term stable electron configuration? A. The atom has 8 shells, like an inert gas. B. The atom has less than 8 shells. C. The atom has the maximum electrons on all its shells. D. The atom does not have a full valence shell of electrons. The answer is C. A stable electron configuration occurs when the atom has the maximum electrons on all its shells. Question 3. Which of the following will atoms do to achieve a stable electron configuration? A. Share valence electrons. B. Gain valence electrons. C. Lose valence electrons. D. All of the above. The answer is D. All of the above. Atoms achieve a stable electron configuration either by sharing, gaining, or losing electrons. Question 4. Using the atomic diagrams below, identify the atom that is a metal. Is it option A, B, C, or D? The The answer is D. Note that D is the only atom that has more than one electron shell, and on its last shell, there are 2 electrons, that is, less than 4 electrons on the last shell, hence it is metal. B is not metal because it has only one shell. Question 5. Which statement about electron configuration is incorrect? A. The second shell holds a maximum of 18 electrons. B. The third shell holds a maximum of 8 or 18 electrons. C. The fourth shell holds a maximum of 32 electrons. D. The first shell holds a maximum of 2 electrons. The answer is A. The second shell holds a maximum of 8 electrons and not 18. Hence, A is the incorrect statement about electron configuration. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.